Hello again, this is Mrs. Denton, and in this video we're going to be looking at right triangle trigonometry as part of the SOL G8 standard. You may know this as SOHCAHTOA, depending on how your teacher taught it to you. Well, on the SOL formula sheet, we get this set of information. We get the sine of theta is equal to y over z. Well, check out your picture here. Theta is representing the angle. Y is representing the side that is opposite of the angle. Z is representing the hypotenuse of the triangle. Then we have that cosine is representing x over z. X is the adjacent side to theta, and z is the hypotenuse. And then finally, we have that tangent of theta is represented by y over x, which is the opposite side over the adjacent side. This is what the SOL formula sheet provides for you as a way to help you remember which trig function goes with which angle side pair. Well, you may have learned it using the phrase SOHCAHTOA. So stands for sine of an angle is equal to the opposite side length divided by the hypotenuse. Ka stands for cosine of an angle is equal to the adjacent side length divided by the hypotenuse. And TOA stands for tangent of an angle is represented by the opposite side length divided by the adjacent side length. Okay, so I have 3 examples here. 3 different right triangles, and in each of the right triangles, we are given an angle and 2 side measures, an angle and 2 side measures, an angle and 2 side measures. The difference on when to use right triangle trig versus Pythagorean theorem is with right triangle trig, an angle is always going to be present. In Pythagorean theorem, you may not see an angle at all. First things first is I think you need to make sure you know which trig function to use for each of the individual problems. So we're going to kind of work all 3 of these problems at the same time so that we can compare. The problem on the left offers an angle of 45 degrees. Across from that angle, all the way to the opposite side, there's a measurement of 6. 6 represents the opposite measurement. We're also given the unknown side, x, and that's across from the right angle. That means x is representing the hypotenuse. The adjacent side has been left blank. We're not given any of that information, and we're not asked to find the length of the adjacent side. Therefore, it's irrelevant to this problem. So, in a problem that uses the opposite side and the hypotenuse to compare, I would be using SO. Sine of an angle uses the opposite and the hypotenuse. This will use the sine function. Let's compare to the next image. Here, we're given an angle of 30 degrees. The side completely across from that is called the opposite side, which is what I'm trying to find. That's what x is, opposite side, opposite from the angle. The hypotenuse across from the 90 degree has been left blank this time. So the second side given to me is adjacent to the 30 degrees. Now, a lot of times students get adjacent and hypotenuse confused. Just remember that the hypotenuse has to be across from the right angle. The adjacent side is adjacent to the given angle. So here I'm going to be using the adjacent side and the opposite side. The hypotenuse is being ignored. Opposite and adjacent are what's being compared in the tangent function, TOA. So this is going to use the tangent function to solve. In my final example, the angle is unknown. The angle is what I'm going to be trying to solve for. Opposite from that angle, the opposite side has been left blank. I won't be using the opposite side. Across from the right angle, there's a measurement of 22. That represents the hypotenuse, since it's across from the right angle. I also have a measurement of 17. 17 is adjacent to the angle. So 17 represents the adjacent value. In this triangle, I'm going to be using adjacent and hypotenuse to solve. Cosine compares the adjacent and hypotenuse. So you can see from this part of the setup, we're going to be using all three trig functions because of what's been given in each problem. The problem on the left has given us opposite and hypotenuse to use, so we use sine. The middle problem gives us the opposite and adjacent to use, so we use tangent. And the problem on the right has given us adjacent and hypotenuse to use, so we use cosine. Now let's get to solving these. For each setup, notice that sine, cosine, and tangent always attach to the angle measure. The side measures are on the right side of the formula. We've already decided we're using sine for the problem on the left. The angle measure is 45 degrees. The formula calls for the opposite side over the hypotenuse. In order to solve this using our algebra skills, we have to get x all by itself. Right now, x is in the denominator of the fraction. I've taught my students to set this up as a cross multiply by putting a 1 beneath the trig value. Sine 45 over 1 equals 6 over x. Now I can cross multiply. X times sine 45 is equal to 1 times 6, which is 6. Now, to get x all by itself, I need to get rid of sine 45. I need to get rid of this multiply. In order to get rid of a multiply, I divide. So I will be dividing both sides by sine 45. This is what I'll type into my calculator. 6 divided by sine of 45 is equal to 8.482, 8.48528, and that number continues on and on. Let's try the next problem. We've already decided we'll be using the tangent function. Tangent of angle 30 is equal to the opposite value divided by the adjacent value. This time, the variable is on the top of the function of the fraction instead of in the denominator. I'm going to go ahead and set this as a cross multiply problem by putting a 1 beneath tangent. 1 times x is x. 7 root 3 times tangent 30 is what I'll be typing in my calculator. I'm going to pause while I do that. 7 root 3 times tangent of 30 is 7. In this last example, something special is about to happen. We've already decided we're using the cosine function. Remember, the angle is always attached to the trig function, so cosine of x equals the adjacent value, 17, over the hypotenuse, 22. Well, something different is happening here. This time, my variable is part of the trig value. I'm looking for the angle in this function. Cross multiplying won't help me here. I need to take cosine off of x. I need to get rid of cosine to get x all by itself. The only way to get rid of cosine is to use cosine inverse. That's cosine to the power of -1. Whatever you do to one side, make sure you do to both sides. So this is what I'll be typing in my calculator. X is going to be equal to cosine inverse of 17/22. When I type that in my calculator, I get 39.4006. And I'm putting a degree on this because X represents a degree measure. I hope this was a good refresher for right triangle trig. This concludes our video and our series on SOL G8.